Welcome to the topic on force, and we are going to look at what is a force, effects of forces, types of forces, and many other concerns about forces. So first of all, we need to know what is a force. Then from there we looked at the SI unit of force. So force refers to a push or a pull that result from interaction of bodies. A push or a pull that result from interaction of bodies. It is that which changes the state of a motion of a body. The SI unit of force is Newton, denoted by capital N. Force is a vector quantity, therefore it has both magnitude and direction, and is represented by a straight line with an arrow as shown. You can see this arrow. There is that part of the line and the part of the arrow. So the length of the line shows the magnitude of the force, while the arrow head shows the direction of the force. There are very many effects of forces that we actually know. But we all know the effects of forces, but there is a way we need to be giving the effects of forces. For example, if I say force make a stationary object to move, I may be lying, because even if you apply a force to a lorry which is at rest, your force will not make that lorry to move. But if you apply a force to a small object at rest, it will move. So we use a word of possibilities that it can either happen or not. So force can make a stationary object move. It can increase the speed of a moving object. It can stop a moving object. It can decrease speed of a moving object. Still, we move on. It can change the shape of an object. We call it can deform an object. It can make an object turn about a fixed point. It is called the turning effect of a force. We will study it in Form 2 as a topic, turning effect of a force, and we will see how forces can cause a turning effects. It can change the direction of a moving object. Force can change the direction of a moving object. Let me give you this an exercise. Which of the effects above that we have just seen in our previous slides can be caused by a push only, a pull only, or a push or a pull? You can try to interact. Then it's just there to ignite your thinking. You can check on it. Now we will start by looking at types of forces. There are very many of them. We are going to see each and how it is being defined. Above it all, forces can be categorized into two. We have what we call the contact forces and then the non-contact force. The contact forces are the one that the two bodies must be in contact for the force to act. For example, frictional force. Non-contact, the two bodies must not be together for it to act. For example, magnetic force. So let's start with gravitational force. It refers to the force of attraction between any two bodies. For example, force of attraction between the Earth and the Moon. It is a non-contact force. Gravitational force of the Earth, that's what we are going to check mostly. It is the force of attraction on bodies towards the center of the Earth. Why is it that always the bodies are attracted towards the center of the Earth? And why is that it's not the Earth that is attracted to that body? Look here. We have these two factors affecting gravitational force. We have the masses of the objects. The larger the mass, the stronger the gravitational force. That is why all objects are always attracted to the Earth. Reason? Because Earth is having a larger mass, so it has a stronger gravitational force. Number two, distance of separation between the two objects. The longer the distance of separation, the weaker the gravitational force. And vice versa is true. Vice versa is true. So what are non-contact forces? What are non-contact forces? I will give you the answer in the next slide. Explain why a ball drawn upward returns back to the ground. Explain why a ball drawn upwards will return back to the to the ground. So reason is here. Non-contact forces are forces which act even if objects are not in contact with one another. They are forces which act even if objects are not in contact with one another. The objects or a ball that is thrown up will always come back to the earth. Why? It is due to attraction by Earth's gravitational force. Good. So that was about force of gravity. Let's look at centripetal force. It is a force which maintains a body to move in a circular orbit or path. It is directed towards the center of the circular orbit or track. It's always directed towards the center of the orbit. Examples of the situations in which centripetal force acts include whirling a stone tied to a string. All of us at some point we've done this. The earth revolving around the sun along its orbit, centrifuge used to separate key from milk, a car moving around a circular track or a road corner. We call it a bank track. You will still learn this when we shall be talking much about uniform circular motion in Form 4. Let's look at magnetic force. Magnetic force is the force of attraction or repulsion due to a magnet. Force of attraction or repulsion due to a magnet. It is a non-contact force. Magnetic attraction occurs between a magnet and a magnetic material or between unlike poles of a magnet, while repulsion occurs between like poles of a magnet. For example, look at this. North and south attraction, south-south repulsion, north-north repulsion, north pole of a magnetic material. Also still south pole can attract a magnetic material. That is it. Upthrust is another type of a force. Upthrust is an upward force acting on objects immersed in fluids, liquids or gases. Fluids refers to both liquids or gases. The definition of the word fluid. Fluid is anything that is capable of flowing due to pressure. So all liquids or gases can flow because of pressure. So upward force acting on objects immersed in fluids, we call it the upthrust force. Upthrust can also be defined as the apparent loss in weight of a body immersed in a liquid or a gas. Upthrust is calculated by weight of a body in air minus weight of a body in a fluid. We will see one example there. It's a contact force because look here, the upthrust must be acting, the object must be in the fluid, so it's a contact force. Examples of situations in which upthrust force acts include balloons rising, swimmers and boats floating, bodies immersed in liquids weighing less than their weight in air. Look at this example. A body weighs 100 newtons in air and 80 newtons when submerged in water. Calculate the upthrust acting on it. Calculate the upthrust acting on it. So this one, we just have to take the weight in air minus the weight in water. So we get 20 newtons as you are seeing it here. So let's look at frictional force. Frictional force, it is a force that opposes motion between two surfaces that are in contact. So it means what? It is a contact force. So because it has to, the two bodies has to be in contact. Frictional force in fluids is called viscous drag or viscosity. It's a contact force, the way I've said, and it acts in the direction opposite to that of the motion of the body. Advantages of friction. They can be applied where? In writing, in braking, in walking, erasing, lighting a matchstick. Those are the advantages of frictional force. Also, apart from the advantages, they have disadvantages. It is useful, yes, but also it can cause some harm. For example, it causes wear and tear. It hinders motion. It produces unwanted heat. It produces unwanted sound. Let me add one. It can cause blisters. It can cause blisters. So now, because at some point we need friction, at some point we do what? We don't require friction at some parts. So where we don't require friction, we reduce the friction by applying the following: by oiling and greasing, using rollers, streamlining bodies, smoothening surfaces, using ball bearings, air cushioning. These are the ones we apply to reduce what? Friction. Yes. Another force is known as electrostatic force. Electrostatic force. Electrostatic force is the force of attraction or repulsion between electrically charged bodies. It is a non-contact force. There are two types of electrical charges, that is positive and negative. Attraction occurs between unlike charges, i.e. positive and negative, while repulsion occurs between like charges, just like a magnet. Examples of situations in which electrostatic force acts include a plastic ruler, a pen wrapped with a piece of dry cloth, or air attracts pieces of paper. A wiped glass window will attract more dust since they are being charged. Those are the electrostatic force in action. So you can see here, up here, attraction occurs between unlike charges. Repulsion occurs between two like charges, that is positive and negative charges. So again, we move on with our cases. Polished shoes rapidly attract dust due to charges left on them during brushing. A nylon cloth produces a crackling sound and sticks on the body when being removed. So that is it. Let's look at our force, another one here: action and reaction forces. Action and reaction are two equal forces acting in the opposite directions. They are contact forces. When a block of wood is placed on a table, its weight acts on the table, so it's the action force. The reaction of the table, that is the opposite force, acts on the block, which is the reaction force. So like this one now, you can see we have the block providing the action and the table providing the reaction force. So that is about action and reaction. We can look at what we call a nuclear force. Nuclear is a force that binds protons and neutrons in atomic nuclei. It's a contact force. When we start about the structure of the atom in Form 2 chemistry, you will get this concept very well. So we can deal with the tension, being our last force for today. It's a force which acts on a stretched bodies. Tension is as a result of two opposing forces applied at each end of a body. It is a contact force still. You can see here, when you apply a weight on a spring, the spring will be under tension, so it will be under tension force. Likewise to this thread. So that's how it is. So we meet next, we start from surface tension as our force. So check my next video about surface tension. Don't forget to subscribe and share about my YouTube channel. May God bless you abundantly. Thank you.